Hi everyone. In this video we're going to go over section 1.2, which I'm calling Introduction to Angles and Polygons. So the first type of special angle that we're going to talk about today is called adjacent angles. Adjacent angles, you can think of these as just being two angles that are side by side. They share a common side and a vertex. So the vertex is where their sides connect. Right? So the vertex is where the sides of the angles connect. They have no other interior points in common, right? So adjacent angles, we'll just use this term to refer to two angles. We'll say like, consider the adjacent angles 1 and 2, right? So they don't have any special properties as far as they're not going to be necessarily equal. They're not going to necessarily add to a certain number. It's just a statement that we make in reference to the location of the angles. So here on the left-hand side, let me change to my laser pointer. Here on the left-hand side, you can see angles 1 and 2 are adjacent angles. That just means they have this side in common here. Right, so this ray in the middle, they share that as a common side. And they're for both of the angles, the sides connect at the same point. So they share that common vertex right there where I'm hovering over with my laser pointer. And then over here on the right-hand side, angles 3 and 4 are adjacent angles. They're just side by side. They share this common side and their vertex is in the same spot. All right, so their vertex or their sides connect at the same spot. All right, so our next type of special angle is called a vertical angle. Vertical angles are angles whose sides form opposite rays. Right, so the sides form opposite rays. You can think of an opposite ray as just a straight line. Right, so for example, if we're considering the angles 3 and 4, sorry, 1 and 3. Let's look at angle 1 and angle 3. Right, we would call these vertical angles because their sides form a straight line or an opposite ray. So we see there's that one straight line. And then their other sides also form opposite rays or a straight line. All right, so their sides form opposite rays. Let me clear that writing. Okay. Angles 2 and 4 are also vertical angles here. You can see that their sides form opposite rays. One special thing to note about vertical angles is that vertical angles are equal to each other. All right, so let's write that down. That's important. Vertical angles are equal to each other. Right, so vertical angles are equal to each other. Right, so in this example here, we would say that angle 2 is equal to angle 4, and then similarly, angle 1 would be equal to angle 2. The measure of angle 1 would be equal to the measure of angle 3. Sorry, I said that wrong the first time. All right, so angle 1 is equal to angle 3, and then angle 2 is equal to angle 4. All right, let's look at our next type of special angle. Next, we have what's called a linear pair. A linear pair is formed by two angles whose non-common sides or non-common side forms opposite rays. Right, so it's formed by two angles whose non-common sides form opposite rays. Right, so let's look at angle 5 and angle 6 here. They're non-common sides. All right, so this is their common side here. This is their common side. Whoa. Let me try that again. That little piece doesn't want to erase. All right, so here's their common side. Their non-common side would be down here. That's the side they don't have in common. And you can see it forms a straight line or opposite rays. And we say that angle 5 and angle 6 here form a linear pair. A linear pair. Now, something special that you do need to know here, an additional piece of information that you need to know, is that angles that form a linear pair, add to 180 degrees. That makes sense, right? Because we're talking about opposite rays, straight line. So here, this angle plus this angle, we formed a straight line now. So that should add to 180 degrees. All right, so angles that form a linear pair are going to add to 180 degrees. Now that's useful. That's very useful information. We'll be using this for the rest of the semester. If they tell you something like angle 6 is equal to 108 degrees, then you could say, okay, well, I know that angle 5 and angle 6 form a linear pair. That means that those two angles have to add to 180. So that means that angle 5 is going to be 180 minus whatever angle 6 is, which in this case is 108 degrees. All right, so 180 minus 108, that'd be 72 degrees. All right, so very useful piece of information there. That the angles that form a linear pair add to 180 degrees. We have two more special angles. The next one is called complementary angles. Complementary, spelled differently than like a compliment, like, oh, you look nice today. So complement here spelled with an E instead of an I. Complementary angles are going to be two angles that add to 90 degrees. All right, so here on the left-hand side, let me switch to my laser pointer. On the left-hand side here, angle 1 and angle 2, you could see that those two angles, if you added them together, they would form this little right angle. And then over here, 25 plus 65 is 90, so that means angle A and angle B are complementary. All right, so complementary angles are going to be angles that add to 90 degrees. And our last special type of angle, supplementary angles. Supplementary angles are going to be two angles that add to 180 degrees. All right, so supplementary means they add to 180. So this is just another name. It means the same thing as linear pair. So supplementary angles add to 180 degrees. Angles that form a linear pair also add to 180 degrees. A linear pair is more specific, like over here on the left-hand side. 3 and 4 form a linear pair. Here, C and D, those are totally, angle C, angle D, those are totally separate angles. They do not share a common side, so they don't form a linear pair, but they are supplementary because 63 plus 117 is 180. Right, so the linear pair is only when they are connected, when they're adjacent angles, and they're supplementary. So you can think of linear pair as kind of like a combination of two angles being adjacent and supplementary. All right, so let's use what we've just learned. So apply what we've just learned and answer this question. Use this diagram below. Is the statement true? Angle 4 and angle 5 are supplementary. Remember, supplementary means that they add, the angles are supposed to add to 180 degrees. All right, so let's take a look. Angle 4 is here. Angle 5 is here. Do those two angles, if you added them together, do those two angles add to 180 degrees? Definitely not, right? They actually add to 90 degrees because they got that right angle marker there. So here we would say, is the statement true? No, it's false. angle 4 and angle 5 are actually complementary. All right, so they didn't ask us to make it into a true statement, but um, just to get in the habit of using our new vocabulary, I added that little statement at the bottom. Angle 4 and angle 5 are complementary, not supplementary. Sorry, I had apparently already wrote all that. Could have saved myself some writing there. All right, let's look at this one. This is a question that I really like, and you can expect to see this one on the test. It says, using the diagram to the right, find all angles that are supplementary to angle FLJ. All right, FLJ. Note that L, the point L, lies on both line FH and line GJ. All right, so L is on that straight line here. So L lies on that line, and it also lies on this line. Right. So let's first take a look at the angle FLJ. So I've highlighted it there. There's angle FLJ. If you want to look at the angle measures, you can see that we've got this 90-degree angle here, and then this 60-degree angle here. So 90 plus 60 would be 150. So we're looking for something that's going to be supplementary to that. So we're looking for a 30-degree angle. You could probably look at this and guess which one of these is a 30-degree angle. The way that I approached this is I said, okay, well, if they're supplementary, they're going to form a linear pair based on the diagram. And that's a straight line. So their non-common sides are going to form opposite rays. Right, so supplementary, meaning adding to 180. Right, so I'm starting from the left side, and I'm forming a straight line. So I said, okay, well, I would have to go all the way over to the ray LG. Right, so I'm going to fill in that little missing chunk there. I've highlighted it in pink. So angle FLG, that would be supplementary to FLJ. Right, so that forms a straight line. Right, you could also go in the opposite direction. So you could start here and say, okay, well, I could go all the way over to LH to form a straight line. All right, so I could go the opposite direction. Start from the ray LF and go all the way over to LH to form a straight line. All right, so there's that little chunk, HLJ, angle HLJ. If you said JLH, that would be totally fine. That is still correct. All right, so angle JLH would have been fine. All right, so I really like this question. You can definitely anticipate seeing this again on the homework, and then seeing it again on the practice test, and then again on the actual test. All right, so similar question. Using the diagram from the previous question, find all the angles that are complementary to angle SLJ. All right, so there's SLJ, that's a 60-degree angle. We're looking for the angle that is complementary to SLJ. All right, so complementary means it's going to add to 90 degrees. All right, so again, we're looking for that 30-degree chunk. So it's going to be the same two chunks as last time. All right, so complementary meaning it adds to 90 degrees. So we've got HLJ, and we've got that vertical angle. So HLJ is a vertical angle with FLG. FLG. All right, so those are vertical angles. Their sides form opposite rays. All right, so HLJ is equal to angle FLG. All right, the second half of today's section is deals with polygons. So the definition of a polygon says a figure is a polygon if it meets the following conditions. It is a plane figure formed by 3 or more line segments called sides. Right, so it's got to have 3 or more sides. Sides that have a common endpoint have to be non-collinear, right? So not on the same line. Sides that have a common endpoint are non-collinear. They're not on the same line. Right, and then each side intersects exactly 2 other sides, but only at their endpoints. Right, so each side is going to intersect exactly 2 other sides, but only at their endpoints. So not like in the middle of the line, not in the middle of the other side. All right, so some common polygons. We have triangles. Triangles have 3 sides. Quadrilaterals. Quadrilaterals are going to have 4 sides. This is just a random quadrilateral that I picked. Quadrilaterals can look a lot of different ways. Next we have pentagons. Pentagons have 5 sides. This is called a regular pentagon. You could create a pentagon, a non or an irregular pentagon or a non-regular pentagon that had 5 sides. Let's see, 1, 2, 3, 4. So that's also a pentagon. That's just an this one would be an irregular pentagon. This one is a regular pentagon. So that's typically what we think of when we think of the shape pentagon. But pentagon really just means, a polygon with 5 sides. All right, next we have a hexagon. Hexagons have 6 sides. This is what a regular hexagon looks like. But again, you could create an irregular hexagon very easily. See, 1, 2, 3, 4, 5, 6. Yeah. All right, so that's an irregular hexagon. Next we have an octagon, 8 sides. There's our regular octagon. I skipped over 7 sides, but you should write that down as well. 7 sides is called a heptagon. Heptagon. Let me just add that right up here. 7 sides. It's called a heptagon. Heptagon. Alright, so an octagon has 8 sides. 9 sides is called a nonagon. Let's write that up here. 9 sides. It's called a nonagon. That might be one you haven't heard of before. And then 10 sides is called a decagon. There's a decagon. That would, of course, be a regular decagon. You could easily create an irregular decagon, but just by drawing some other shape that had 10 sides. All right, so let's look at an example with polygons. Use the figure to the right to answer the following questions. Use a comma to separate answers as needed. All right, so first we are just naming the vertices of this polygon. All right, so the vertices are going to be where the sides connect. All right, so we are just writing down what the vertices are. So we have F, M, L, H, and G. F, L, M, H, and G. So you can see I've written them in a different order here. It does not matter the order that you write the vertices in. All right, so super simple, easy question. Just name the vertices. And the vertices are where the sides connect. All right, next we're going to name all the sides of the polygon. All right, so we're going to name all the sides of the polygon. All right, so let's start here. That would be side FM. We have side FG and ML. Can you think of another side that I haven't named yet? So take a look at what we have named. FM, ML, and FG. So what have we left out? So that would be line LH, or side LH, and side HG. All right, let's see. This has 1, 2, 3, 4, 5 sides. So that would be a pentagon. Pentagon. All right, name the included side of angle G and angle H. Angle G and angle H. What is the side that is included between those two angles? Well, it would just be this line right here, so side GH or HG. All right, so you could call it G line or side GH or side HG. Either one would be fine. Next, we have find the measure of angle C in the quadrilateral. Right, so we've got this quadrilateral here. It's got 4 sides, and then it says the figure is not drawn to scale. Right, so think about if you drew a line straight down the middle of this quadrilateral. Right, so as of right now, I haven't told you anything about what the angles in this quadrilateral are going to add to. So I want you to think about if you took this quadrilateral and you drew a line straight down the middle. Now, what two shapes did that just make? You see 2 triangles, right? You see the top triangle and the bottom triangle. Okay? Well, the angles in a triangle add to 180 degrees. All right, so each triangle, all of the angles are going to add to 180 degrees. So 180 plus 180 is 360. So all the angles in a quadrilateral are going to add to 360 degrees. All right, so let's add this up and figure out what the measure of angle C is. All right, so far we've got 115 plus 100 plus 55. All right, y'all grab your calculator, add those up. Pause the video if you're still working. All right, so those add to 270 degrees. All right, so we have accounted for 270 degrees. We know that all 4 of the angles are supposed to add to 360. So let's do 360 minus 270 to figure out what's left over. What is 360 minus 270? Pause the video if you're still working. All right, 360 minus 270 is 90 degrees. So the measure of angle C, the measure of angle C, is 90 degrees. Okay. Now, a little bit harder. It says find the measure of each variable. We've got 2 variables here, y and z, so we need to figure out both of those values. We know that 95 plus 85 plus y plus z. All right, so 95 plus 85 plus y plus z has got to equal 360. It doesn't really help us at this point because we have 2 variables, so that doesn't help us narrow down our options. But we can take a closer look. We have one additional piece of information over here about the angle Z. We've got a linear pair. It's forming a linear pair with this angle 109. Right, so angle 109 degrees and angle Z are forming a linear pair. That means they add to 180 degrees. All right, so we can figure out what Z is from that. We're going to do 180 minus 109. So subtract that from both sides. That cancels out, so Z is 71 degrees. All right, so Z is 71. If Z is 71, we can now figure out what Y is. All right, so we're going to add all those up. Remember, we know that these have to add to 360 degrees. All right, so 71 plus Y plus 95 plus 85 has got to add to 360. So go ahead and add up 71 plus 95 plus 85. That adds to 251. Right, then we're going to subtract 251 from both sides, and that gives you y equals 109. That's actually a special type of angle that's called alternate interior angles. We'll learn more about those later on in the semester. All right, so triangles are going to be really important in this class for the rest of the semester, so we're going to take a few minutes just to talk more about the specific types of triangles that you will encounter. So we have just learned that a triangle is a type of polygon that has three sides. We can kind of combine those two definitions to make this definition. It says a triangle is formed by three non-collinear points connected by line segments. All right, so three non-collinear points, that just means they're not all three on the same line. And those 3 points are connected by these little line segments, which we call sides. All right, so I would name this triangle ABC. All right, so you can see the notation there. It's got a little triangle, and then A, B, C, that's just the vertices. A, B, and C are called the vertices of the triangle. And the line segments that join the points together are, like we said, called sides. The first type of triangle that you might encounter is called an equilateral triangle. That's where all three sides are congruent, or another way to say that is that all three sides have the same length. Right, so all three sides have the same length. The second type of triangle that you might see is called an isosceles triangle. Isosceles triangle. Isosceles triangles are triangles where at least two sides are congruent. Right, so at least two sides are congruent, or at least two sides have equal length. Right, and the last type of triangle in regards to the length is, or the sides, is called a scaling triangle. Scaling triangle. A scaling triangle is a triangle where no sides are congruent, so no sides have the same length. So all three sides have a different length. And you can see that that's noted here in the figure with these little tick marks. So it has one tick mark on this side on the right, two tick marks on the side on the left, and three tick marks on the bottom. That means that each of these represents a different length. All right, in regards to the angles of a triangle, we can refer to a triangle as an acute triangle. Acute triangles are where all three of the angles are less than 90 degrees. All right, so if all three of your angles are less than 90 degrees, you would call that an acute triangle. A right triangle is where at least, or excuse me, one angle is a right angle. And remember that right angle is a 90-degree angle. An obtuse triangle is a triangle where one angle is an obtuse angle. Obtuse means greater than 90 degrees. One angle is an obtuse angle, which means greater than 90 degrees. An equiangular triangle is going to be a triangle where all three angles are congruent. So all three angles are equal. All right, so all three angles are equal. So we're going to be classifying triangles. This is something that you'll see again on the homework and on the practice test and on our actual test. So we're supposed to classify the triangle by its angle and its sides, and we're supposed to use the most specific name. All right, so we're going to think about the length or the sides, the side lengths, and the angle measures. All right, so here we see this triangle has three acute angles, so they're less than 90 degrees. 56 degrees, 82 degrees, 42 degrees. So those are all less than 90. So that's definitely an acute triangle. All right, so judging by its angles, we would call this an acute triangle. None of the sides are labeled as being equal, so we don't see any tick marks indicating that any of these sides have the same length, so we would call this acute scaling. An acute scaling triangle. All right, here's our next triangle. We can see that it's got one angle labeled 119 degrees. That is greater than 90, so that's definitely obtuse. It's got two sides marked as having equal length. Sorry for the graininess in this picture. It's got two sides being marked as having the same length. So when two sides have equal length, we call that an isosceles triangle. So this is an obtuse isosceles triangle. All right, here we have another triangle. We've got a right angle marked, and we've got two sides being marked as having equal length or being congruent. So what would you call this triangle? I would call this a right isosceles. Right isosceles. So it's got a right angle, and it's got two sides labeled as being congruent. Right, so that's the definition of isosceles, two sides being labeled as congruent. Right, here we have another triangle. Again, sorry for the quality. So we've got three angles marked in here, 60 degrees for each, and then all three sides have one tick mark, so that would indicate that all three sides have the same length. Right, so we would call that equiangular, equilateral. And really you can just use one of them. You can just say equiangular. If the angles are all equal, then it's going to force the sides to all have the same length. So you can just say equiangular or just say equilateral. All right, find the value of each variable in the figure to the right. All right, so it looks like x and y are vertical angles, so if we can just find x, that's going to give us y for free because we know that vertical angles are equal. All right, so we have this little triangle here. We know that all the angles of a triangle have to add to 180 degrees, so 73 plus 31 plus x has to add to 180. All right, so if you do 73 plus 31, that adds to 104 degrees. Then we're going to subtract 104 from both sides to get x by itself. So x is 76 degrees. Now x and y form a vertical angle. Their sides form opposite rays. So we're going to get y for free. We know that y must be the same thing as x. All right, so since those are vertical angles, y must also be 76 degrees. Right here we have find the measures of angles 1, 2, and 3. Right, angle 1 is definitely going to be the easiest to find. Right, so just looking at this triangle on the left, we have 35 degrees, 85 degrees, and then angle 1. Right, so let's figure out what the measure of angle 1 is. 35 plus 85 plus angle 1 is 180. 35 plus 85 is 120. Subtract 120 from both sides, tells us that angle 1 is 60 degrees. All right, so angle 1 is 60 degrees. Now let's find angle 2. Angle 1 and angle 2 form a, do y'all remember what it's called? Angle 1 and angle 2 form a linear pair, which means they're supplementary. They add to 180 degrees. All right, so if angle 1 is, what we say, 60? Yeah. Angle 1 is 60 degrees plus angle 2 must add to 180 degrees. All right, so subtract 60 from both sides. That's going to tell us that angle 2 is equal to 120 degrees. All right, so now we know that angle 2 is 120 degrees. We can easily find out angle 3. Looking at that triangle on the right-hand side, that would be 120. All right, so 120 plus 40. Whoops, I missed a plus 40 in there. Let me add that in. Plus, let's see right here, plus 40. So 120 plus 40 plus angle 3 is 180 degrees. So that's going to be 160. plus angle 3 is 180 degrees. Subtract 160 from both sides, and angle 3 is 20 degrees. All right, so using all of that stuff that we learned about, you know, the angles of a triangle, linear pairs. All right, so, and also throwing in some new notation in here. So using this new notation with the angle symbol. All right, so hopefully this is all starting to come together for you. All right, here we have kind of a similar problem. Find the measures of the numbered angles. I can see that angle 3 and 59 degrees form a linear pair, so they add to 180. Here, 32 degrees and angle 1 are complementary. They're supposed to add to 90 degrees, so we can figure out 1 pretty easily from that. So I think this one is not too bad. So it looks like there's a lot to do, but we can get a couple of these pretty quickly. All right, so let's start with angle 1. Angle 1 and 32 degrees are supposed to add to 90 degrees. They're complementary. So that means that angle 1, if we subtract 32 from both sides, angle 1 must be 58 degrees. All right. So we've got 1 done. Let's go ahead and get angle 2. Looking at the triangle on the right hand side, we know that angle 1 was 58. Once again, I'm missing one of my angles. All right, so angle 1 plus angle 2 plus 59 degrees. All right, so all those are supposed to add to 180. All right, subtract, well, sorry, we said that angle 1 was what, 58? So 59 degrees plus 58 degrees plus angle 2 is 180 degrees. 59 plus 58 is 117. All right, so 117 plus angle 2 is 180 degrees. Subtract 117 from both sides. Angle 2 is equal to 63 degrees. All right, so far so good. This is 58 degrees. This one is 63 degrees. Now let's do angle 3. All right, we said that that forms a linear pair with 59 degrees. So those are supposed to add to 180. So angle 3 plus 59 degrees needs to add to 180. Subtract 59 from both sides. That tells us that angle 3 is 121 degrees. All right, and how are we going to find angle 4? These three have to add to 180, right? So 32 plus 121 plus angle 4 have to add to 180 because they're all the three angles of that triangle. All right, let's see. 32 plus 121 is 153. Subtract 153 from both sides, and angle 4 is 27 degrees. All right, so kind of a fun little exercise, I think. Hopefully you thought so too. All right, so that is everything for section 1.2. So now what should you do? You should go work on the section 1.2 homework. You can find that in D2L. And if you have any questions, please make sure that you email me and let me know. And I'll be happy to either answer you in the email or record you a short little video or maybe schedule a meeting with you to discuss the problem. All right, so I'll talk to you guys soon. Thanks for watching.